Hello everybody, welcome to the show. Let's pretend you didn't see that behind the scenes intro there before I got my green screen turned on. I'm SM Sith Lord. This is the bi-weekly build stream. It's the 2-hour build stream where I spend 2 hours each session trying to completely make something, but I don't always finish within that 2 hours. Today I'm going to be starting something new, and today is going to be more like a demonstration thing. So I probably won't finish what I'm making right now. Let me go back and explain what I'm doing before I start doing it. So here on the stream, by the way, welcome everybody, wherever you're watching from, whether it's Twitch, LinkedIn, Twitter, welcome. Today, normally on the stream, I build either in the easy mode, as I call it, builder, that's all inside of the Somnium desktop client, and then sometimes I build web worlds, which is stuff like Blender and Photoshop, and then I export it and bind it to the web parcel. So there's easy mode where you're just using the Somnium builder that you get from when you download the client from the website. And then there's medium mode where you're putting stuff together in the Somnium Web Worlds SDK, which is on the Play Canvas engine. And then there's hard mode where you're putting together stuff in the Somnium Unity SDK, which is like if you're making VR worlds, ultra high fidelity with fancy shaders and stuff like that. We will be doing a little bit of medium mode today, but we're going to try to do a bit of complex things in it. So the first thing is we're going to be making a web world. So we go to the web world GitLab. You can find this by finding the Somnium Web Worlds Medium article. It'll tell you all about it and it'll link you to here. Here's a bunch of instructions that you can read. We're going to skip those because I'll be demonstrating stuff. And I'm going to get straight to installing, or I'm going to straight to setting up a brand new blank Web Worlds project. Even though I'm not going to use it until later, I'm going to do it right now so we can see how it works. And then I'm going to jump into 3ds Max. You could use Blender or Cinema 4D or whatever you like to do animations in. But the key for today is animations, because I'm going to be making animations to make a thing spin, make it move around on a track, and just try to get some motion into a web world so everybody can see what it's like to do such. So I just downloaded the zip for the Web Worlds template version 0.1. Now I'm going to go to my Play Canvas project list here, and I'm going to click Import Project. And after I click that, it's going to ask me which zip I want to include. Did I not click that? I may have not. There we go. And the zip is one that I just downloaded. It's right here, Web Worlds template. Well, it looks like I downloaded it twice. Whatever. Upload the zip that you just downloaded of the Web Worlds template, and you are just about ready to go. It takes a moment, okay, and it names it Web World template because you just imported that. So I'm going to go to settings, and I'm going to name this one. No description, and the title will be Animation Examples. Animation Demos. Save. Editor. Okay. Now, this is the vanilla Somnium Web Worlds SDK 1.0. And when you drop into there, you can immediately go over there to the launch button and start testing your build in the test environment. Out of the box, like after you just download it, like I did, you spawn into this, which is a bit of a demo world with a runway, and it shows you what a web browser object's like and has an example about physics here. But we're going to take it up a notch, and we're going to add some moving things to this scene. Let's add a couple moving things. Now, you could download models that have animations from Sketchfab or wherever and import them. That's cool, but we're going to go a step harder than that. And instead of downloading something with an animation, I'm going to make an animation in 3ds Max here. We're going to export it, and then it's just going to be the animation here, some bones moving around. I'm going to export it, import it into the Play Canvas, the Somnium Web Worlds SDK there in the Play Canvas editor, and then I'll have the bones flying around, and I could drop stuff into them to make them do things. So we're going to do a couple things like that. First off, let's start with a rotating object. Okay. we're going to make a bone. Let me think here. Yeah, bone. Let's make a bone. This step, and pretty much everything I do in Max here, it'll be a little bit different depending on what software package you're using for 3D modeling and animation. I'm using 3ds Max here, but it's very similar no matter what you're doing. This looks way bigger than it should be. Why is it doing that? Don't know. It says it's 100% zoom world. Scale. That's not it. Okay, 1 second. There we go. Now, why is my bone looking so weird? Is the question, and I'm sure the answer is somewhere over here, but I don't know if I'm even going to look for the answer to that question. Let's just make another bone. Bones? Is this one too large? No, I don't know where my bone looks so weird in this app, and I don't think that it matters. So let's act like it doesn't matter. I'm just going to put my bone over here in the middle. I'll make sure that it's oriented the way that I want, which is not oriented. And for the zoom, it doesn't matter. Or for the scale. So I'll just scale it down to there. Okay, well. Now we have a bone, let's move it. Now what I'm going to do with this bone is I'm just going to rotate. So, depending on your animation tool, I'm going to set my timeline here to 200. No, let's see here. I'm going to set it to 300. Okay. We're going to set this thing. Oops. Set this thing here. And then I want to set it again at 150, but I want this one to be rotated. Do I have angle snap on, is what I'm wondering. I guess we'll see. I do not have angle snap on. Why don't I see angle snap up here? Here we go. Yeah. No, that's not it. Oh, because this is a bone, I'm seeing different tools up here. That's okay. All right, we won't worry about angle snap right now. Let's just rotate this thing. I'm going to rotate it a full, not a full 360. I'm going to make it like 359, just so it kind of knows what direction it's supposed to go. And we'll see that it is slowly spinning over here. And then by the time it gets to 100, I'm going to want it to be, let's duplicate this, or just shift it. Yeah. I want it to be exactly where it started at frame 300. Okay. And now if I click play, we see that I have a bone that rotates continuously. Now it kind of slows down there. Oh, then it goes back the other direction. That kind of makes sense. We don't want that. So let me just mess with my animation a little bit more. I'm going to delete that thing after all. And over here at 300, we want it to continue moving around until it gets back to 360. About. Oops. I forgot to turn on animation. Now, I'm just making something spin. That is a bit simple. You might want to do something more complex in the end. However, the thing spinning is actually going to be highly useful to me. And I'll show you what I mean momentarily. Let me just click play here in the preview, make sure it's spinning the right direction. Yeah, it's spinning around. It's slowing down there, but then it keeps going and then spinning around, and then it gets back over here. Good. Now, it comes to a stop when it does a rotation. I could go to the animation dope sheet and change the blend method to make it move smoothly, but that's not the biggest thing I'm trying to show here, because that's going to be different in each application. So I just made a spinning bone. It's pretty smooth with its spinning. It could be more consistent, but it's all right. Let's just export this thing, get it into the WebWorlds SDK there, and see how we can use it. So how do I export it? File, well, in this application, it's File Export FBX. It'll be the same as in your application. You're going to want to export it as an FBX. And this one is going to be called simplespin.fbx. And there's only one bone. It should be real small. Let's go over here to the PlayCams engine here. And I am going to upload I'm able to open my folder there. I'm going to upload this file that I just saved, and then you'll see. It's taking me longer than I was hoping to open up this. There we go. My display settings were confusing me. Okay, now let's upload this simplespin.fbx. I just drag it and drop it from the local folder file explorer down to the actual asset explorer in the game. Now that I have it here, if I drag it and drop it in, I see that there's nothing here because remember, it was just a bone. It was an empty bone. The bone is actually here. It's called bone 01, but it's not actually moving. Let me set its scale back to 1. You don't want to scale your bone. You want to leave your, I scaled my bone before I exported it. Don't do that. You could always balance it out like I did there, but you do not want to scale your bones. And here's why. I'm going to put an object inside of that bone. What kind of object? Well, how about a box? Simple old box, okay? I'm going to put this box inside of that bone. I'm going to parent it in a hierarchy. Now, this is why it was important that that bone wasn't scaled. If that bone was scaled, when I put this box into it, it would be scaled because of the way the hierarchy works. So I didn't want the bone scaled. I want everything to remain the same scale because I'm not worried about scale with this thing, this FBX that I exported. I'm worried about the motion. So right now, the box is parented to the bone, but the bone is not moving. Here's why. We have to assign an animation controller to this rig here, the Simple Spin FBX that I imported. We need to assign an animation controller to it and then put the animation on it. So the first thing is you click on Add Component, Animation, Anim, for animation. Now we're almost there. We're not quite there because in order to make an animation work, we have to define what's called an animation state graph. We're going to make the easiest animation state graph in the world. We won't even have to edit the graph. We just got to right click on the Asset Explorer here in an empty space. New Asset, Animation State Graph. Now that we have a blank default animation state graph, we can go back to our rig here that we imported from the FBX, drag and drop the animation state graph into where it says state graph. And now we're ready for an animation. And here is our animation. It's the only one that imported from the FBX with the word animation on it, right there, take 1. So we're going to drag and drop the animation into the FBX rig that we imported, and now it's there. Now it should just work. So you go and you click on the launch button to test, and you pop in here, and we just gotta walk over there, and hey, it is working. It is working, and it is applying scale. Let me get rid of the ball. We don't need the ball. So I tried to change the scale after I imported it, but that didn't work because it was an animation and the keyframes were already set with the scaled bones, which is pretty cool. We could do something cool with that, but that's not exactly what I show right now. Instead, let's go and let's fix this issue. And this is the workflow that you're going to be going through if you want to adjust your animations and re-export them. I want to adjust my animation and re-export it. Specifically, I want the bone to be non-scaled. So we'll just reset everything to 100%. Okay. And let's see here. I believe it stays 100% the whole time because I didn't animate the scale. Let's make sure. What's your scale at this frame? It's 100%. Even if we're trying to set the key? Even if we're trying to set the key. Okay, so I fixed my animation by taking away the scale. I just need to re-export it. So File, Export. And we'll name it the same thing. It's important you name it the same thing because of what I'm going to show you next. So now I have an updated version of my FBX. I want to upload it, but I need to make sure that it's going to go into the folder that I want it to go into. So to be sure that, I'm just going to go in here to Settings, in the editor here, go into the Settings for the editor and go to Asset Tasks up on the top there. And I'm going to uncheck Create FBX Folder. Okay. Now, that means that when I drag and drop an FBX in, it's just going to put it into whatever folder in the Asset Explorer that I drop it into instead of creating a new folder. Usually, creating a new folder is cool, but sometimes you don't need that if you already have a folder. So that's where you control that setting. Anyways, drag and drop the new FBX. Oh, there goes my webcam. I should be able to fix that. Fix that, and then I'll continue. Hey, and we should be back. If we go over here and click. Nope. Okay, my webcam. I have to figure out how to fix. I'll try one more time. And if I can't do it then, I will continue sans webcam. Hey, there it is. It's back. All right, wonderful. So I've imported the new version of the FBX back in, and now it is time to do nothing. Yeah, so everything should have updated by itself. So all that I should need to do is come over here and refresh my test page, and my cube should no longer be squashed because I changed the animation for the bone not to be scaled, and it worked out perfectly. All right, and there it's doing the animation where it spins a little bit, then it comes to a stop, and then it spins a little bit. Now, spinning cube. Let me throw a spotlight on this thing. We're going to do a new light. It's going to be a spotlight. Throw it up over here. This other point light I'm going to change to be a directional light. Tweaking the lighting a little bit here. Bluish hue. Okay. Just do 0.5, 0.7. Okay. There's the new lighting situation. Let me turn a shadow on that spotlight just so it looks cool. Now we're casting shadows there. Spinning object. All right, but what could you use a spinning object for? Well, I made the mock-up storefront. Let me try to get into some of the chats here real quick. So I don't miss too much of the chat. The other day, on Monday, I finished off that mock web world storefronts. So today, and one thing that would have been cool in it would have been if my shoes, my 3D shoe model that I put in there, was actually spinning instead of laying down there static. And that's what you can do with these kind of animations. So imagine that cube was the tennis shoes, the basketball shoes, and you would want to do something like this. You'd want to do a pedestal or some kind of display stand that looks like this. And you would not want that to spin. You'd want that to just sit there. What you would want to spin is imagine that this box is actually shoes. I'm just using a box to represent the shoes, but imagine that box was actually shoes. Let's throw it up here. Let me rotate the box a little bit to make it look like it's at an angle. There, that should make it look a little more interesting. Okay, so now when I look at this, we see that it's the object sitting above the pedestal, the display stand that is rotating. It's got this pretty interesting rotating mechanic where it comes to a stop there, then it eases back in while it goes again. If you want that, cool. If you don't want that, you gotta break out the dope sheet and get a little bit advanced with your animation techniques. But we have the bone in there for spinning. Let's use the same thing again. Let's say that we had two spinning objects. Okay, well, I would just put another copy of my rig here, my simple spin rig. I'll move it over here. I'll give this one over here its own kind of pedestal area. Okay. And what I want to do here is add different objects that get spun around to it. So, parented to this bone, I'll make a sphere. And I'll make a cube. And then this rig, it doesn't have the animation thing on it. I should have cloned the other one that already had the animation on it, but it's no big deal if we just set this up again and drag and dropping the animation state graph and then dropping the animation into that. It's all rigged up. I'll bring up the whole thing a little bit so it's not so close. And now we got two things, two display pedestals sharing the same animation rig. Try to fix my camera here. Sharing the same animation rig, doing the same animation. And it's great to share things between different objects in your scene because that's optimal. It reuses assets, it's faster loading time, and all that kind of good stuff. Okay, there is a simple spinning one. Now, how about something more complex? We want something that moves along a track. All right, I did this for one of the first web worlds I made on the stream, the Halloween web world that had the witch flying around. We're gonna do something like that. All right. We're gonna go back to the 3D animation program. I'm gonna just start a new scene here because this animation track that I'm making is not related to the spinning one. There are two distinct things that I want going on. Let's make a teapot as our example object. And we are going to define a path for this thing to move on. Let's make it a closed path. This is another one of those steps that will be different depending on what 3D animation software you prefer. I'm in Max here, so I'll start with a circle. And then I'll edit that spline to make some of the circle up high. And I'll do... let's make it interesting. Let's add some more vertices to this thing. One there and one over there. And maybe one over there. Okay. And I'll take this new vertice and I'll move it in like that. Going down. Alright. This one will want to be going weird like that. And then this one we'll put over here. Okay, that is an abnormal track that we have there. And I could do any track. It doesn't have to be like this this circle that's mutated. It could be any kind of spline, depending on your 3D animation software, because the next thing I'm going to do is I'm going to bind this this. That wasn't right. That wasn't right. Let's try that again. Spline animation. Animation. Constraint. Path. There we go. All right. Now when I click play, that step will be a little bit different depending on which app you're using for 3D animation. My teapot is flying around. Cool. I don't like how it doesn't follow, it doesn't look where it's going. It just slides around crazy style. Let's fix that. Let's tweak a couple things about this. So I'll click over here. What happens if I extend my timeline to 400 frames? Is it going to move slower? Well, only if I do this. Okay. Now, when I click play, my teapot's moving slower, but it's not facing the direction that I want it to face. So I'll just go over here, and I'll tell it that I also want it to affect rotation. No, that's not it. There we go. Now it's flying around like a ship. Click play. There it goes. Okay, now, I don't want a teapot. Wow. So let's delete the teapot and do those last few steps all over again. I want a bone because I'm going to attach something to this. So to create a bone, I go over to Systems Bones. All right, there's my bone. Make sure it's not rotated and that it's scaled 100% and not specially scaled. Cool. And we're going to do the same thing again here. Animation, constraints, path into that. And then I'm going to tell it that I want it to follow. And I already have it loop, so we look good. Now I have my bone going around the path. Cool. I'm ready to export. So I'm going to export movement path as an FBX. I'll just ignore everything and see how it turns out. And if it doesn't turn out well, then I'll go back and I'll worry about what those messages said, because usually they don't matter. Now, I want to create a new FBX when I drop this in. So I actually went back to my settings and re-enabled Create FBX folder. Make sure that I go back to my root folder there before I drag and drop movement path.fbx into my Asset Explorer. It created a folder for me, it uploaded the FBX, it converted it to a GLB, and it created the template for me. But I don't see an animation. That's no good. That means it didn't export the animation like it was supposed to. So I'm going to have to go back and try to export it again like I mentioned. I'm going to turn off creating a new FBX folder because I already have that folder. But why didn't my animation export? That's a good question. Let's see. What were my options when I exported? What were my options for animation? These were my options. I want to bake the animation. I might need to make my object not a bone. Let's see, what happens if I just click that and I say that I just want to export selected. Again, I don't have, I do. Did I have that the whole time? Wait a second, file, export. Okay, yeah, I guess I did have it the whole time. What I needed to do probably, we'll see, was I needed to check the box that said animation and make sure that it's going to bake my animation. It looks good. I'm exporting animation, I'm baking the animation. I clicked OK to export it. Let's try to re-import it over here and see if we have anything different. There it is. So you have to be sure to check the box in whatever app that you're exporting with to bake the animation. Now that I have this animation baked, I'm ready to use it. I do not need to create a new state graph because I already have a state graph, but animation state graph. But first, let's get this template into here. There's the template. It's empty though, so I need to put an object into my bone. Here's my bone. Not sure exactly where my bone is. But I'm going to put something into it. We're going to add... I want to know what direction it's going, so we're going to add a cone. Where's my cone? I don't know. 3D cone. There's my cone. There's my circle. Oh, it was way over there. Why was it so far? I don't know. Let's just see what happens when I put my cone into my bone. And then on the rig, I'll assign it the animation. It needs an animation state graph. I'll just use the same one that I used last time, but this time I'm going to use the animation for this model. Okay. Now after I assigned the animation, then it put things in the right direction. I mean, in the right place, but I can tell that my cone needs to be rotated to point forward. All right, let's see how that looks. Oh, I'll move it a little bit so it doesn't go straight to the middle. All right, now if I go over here and I refresh, I want to see my cone flying along the path. I don't think that I see my cone flying along. I don't know what's happening. Where did my cone go? That's not right. Oh, there it was. It is moving so fast. Oh, so fast. Much faster than I had hoped. Why is that? Oh, why is that? That bone. I might need to scale this thing down here. Let's see. Oh, maybe. I don't know what's going on. Oh, wait, I saw my cone there for a second. It's moving too fast for me. I need to debug this. So I'm going to go back into S-Max here, and I'm going to... Is this thing huge? Is that what's happening to me? This thing is huge. This thing might be huge. Let me make a 1 meter box in the center here and see what that looks like. Oh, wow. Okay. So my animation is working correctly. It's just that it's gigantic. That's 1 meter. And if that's 1 meter, that animation is insane. So let's fix that animation. Be much smaller. Around my 1 meter cube here. Okay. Let's make sure that it animates the way that I want it to. It does. Cool. Let's file, export this thing again. Make sure that we are baking the animations. We are. And I'm going to re-upload the thing here after I undo my scaling. Okay. It's in there, but it's way too huge. So I'm going to re-upload the new version that I made. And this will help things out some. Okay, it still looks pretty huge to me. And shrink it down some. It looks like it might be rotated also. It is doing it. It's not rotated correctly. It is acting a little nuts. Oh, maybe it's because I did not reset my X form here. Yeah, that was it, probably. Was that it? No, that wasn't it. Something with my units is wrong. You know what? I should check my units over here. Customize units. Using meters there. And I'm using meters here, but I think the other engine might be in centimeters. So that could be why it's so huge. So let's try changing this to centimeters and re-exporting. Let's just see how that exports. Drum roll. That's more like it. That must have been it. The engine was in centimeters. I was feeding it meters. Oh no. No, it was doing that itself when I okay. Let's see what's going on here. I'll bring this thing up. I need to rotate that thing. Like 90 degrees so it can face where it needs to face. All right, now I got it moving with the direction. I have it facing the direction that it's moving. I should have picked I should have created a more simple path for this thing to go on. But hey, there it goes. It is going. Let me see if I give it its own animation state graph, if that changes anything. Well, there it goes. It's just how it goes. Oh, well that's how it's supposed to go? It does get a little crazy. On those turns, it is going a bit sharp, isn't it? Oh, wow. That would explain a lot. I had my thing set up as an offset. All right, that was the problem. I found my problem. And now my animation looks correct. Okay, let's bring it down here. My problem was the cone that I attached to that bone, I attached it on an offset. And because I attached the bone at an offset, or I'm sorry, it's because I attached the object to the bone at an offset, it was animating at an offset. And it looked weird to me, but it was actually doing what it should have done in that case. Now, since I centered up my cone onto that bone, now it's moving exactly like it does in 3ds Max. And there is our cone flying around. Just like we wanted, along that weird shape. So, the lesson that we learned there together by me falling into that gotcha is when you parent an object to your bone in the Web Worlds SDK over here, make sure that the object that you put underneath your bone is at 0 offset for position, unless you wanted it at an offset. Same thing with rotation. I actually did want to rotate this one so it would point towards the direction that I was moving, and it is properly pointing towards the direction it should move now. We are all good. So, how about let's make this a little more interesting. Let me put a couple floating spheres around here. A few floating spheres, because I'm going to attach a light to that object that's moving around, and that is really going to spice things up a bit here. So on this bone, I'm going to add a new entity, and it's going to be an OmniLight entity. And we'll make the OmniLight red, and we'll make it intense, but not have too much of a reach. So it only really lights up the stuff it gets near. Now, as the red object moves around, it has a red light on it that lights up the things it goes near. Now it's starting to look cool, right? Imagine that with a cool skybox and some distance fog and some better lighting. Let's improve this lighting a little bit. Here's a trick. This is actually a directional light. I'll name it directional light, so it's easier to see. I have one directional light in this scene that's casting in this direction. Let's add a secondary directional light, kind of like an ambient light, and we'll spin it to be facing the other direction. And we'll make it a different color. We'll make it a little bit of a green. But we'll make it not as intense as the other one. Now you see how 3D that made everything look compared to just taking lighting from one angle. Now we're taking lighting from two angles, and it's because of that everything looks really 3D. And using two directional lights like that is a really good way to have a nice lighting effect without being too process intensive, because those two lights that I added, they're not generating shadows. They're the kind of the most simple lights that you can add other than a spotlight. And just two of them gives you global illumination everywhere, so to speak. Not actual like glowing textures, but it globally lights your scene from two angles, so you can walk around anywhere in your scene and you'll be able to see from the lighting. Then we have this top-down spotlight here casting shadows, and then we have that thing floating around with its redness. Let's make this more interesting. Let's make that little cone actually look like it's glowing by giving it an emissive texture. Okay, I'll just create a new texture right here, and we'll call it Glow Red. With the glow red there, we want to make sure that the emissive on it is set to red. And the diffuse I'm going to set to black so we can be all red. And let me make sure that I assigned that to my cone, and now my cone is definitely glowing red. And let's make this have a little bit more reach. So that's 5 there. Let's see how that looks. Okay, we got the blue thing moving around and it's casting blue light. The red thing flying around and it's casting red light as it moves around. And it's working. How about we do one more animation and we'll export a blue light moving around, and with those two things moving around, that'll be the last track animation thing that we need to set. Let me think here. Do I want to set a track animation, or should we do something different? We could do a swaying spotlight. Let's do that. This spotlight, actually, let's add an animation to the spotlight right here that makes it kind of sway back and forth like a grenade just went off next to this hanging lamp. Yeah, like we're playing Counter-Strike. So let's reset this to a brand new scene. By the way, you would want to save your scenes if we weren't just making a demo. I was just making a demo, so it's okay if I lose those scenes. Let me make sure that my units are set up the same way that they were a second ago. Centimeters, sure. Do I want centimeters? I probably don't. I don't want centimeters. Play canvas is in meters. I said it was in I thought it was in centimeters a moment ago. That is incorrect. I had other issues that were impacting me. Play canvas engine is in meters. The Somnium Web Worlds SDK here, it runs in play canvas, so you want to match up your units with that. Meters. Did that say miles or meters? Meters. Okay. Meters. Meters. Good. 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 Now, I want to make a bone. I want this bone's rotation to be not rotated. I want it to be not scaled. It's not scaled. Okay. And I want it to be at the origin. All right. I made my bone way too long, and that's just going to visually throw me off. So let me make another bone. Make this bone not so long. And then I'll do the same things to it. Rotation, zeroed out. Position, I'll zero it out here, and I already know that the scale is zeroed out. Now, I want this to be a pointed down and be rocking back and forth. So let's point it down. This. Okay. Now we're going to animate this thing. I want it to be swaying back and forth at a medium speed. So I'll put 300 frames in this thing. And I'll start animating it over here. And then at about 60, let's make it swing over here. And then over here at 120, we'll swing all the way, no, at 200, we'll swing all the way back like that. And then at the end, we'll be back where we started. 300. All right, so with that, if I click play, we see that, imagine a spotlight attached to that. We want a slow swing spotlight to the left and to the right and to the left, repeatedly, forever. Looks like we got it. Let's export this. Let's see how it looks. File, export. Spot swing.fbx is what we'll call this one. Animation, and it's baked, looking good. Now, go back over here to the Web Worlds editor in Play Canvas, and here's the spotlight. But what we want is to import another FBX, and I want it to create a folder. I could create a folder myself, but I'll just do this. Check that box and move in spot swing.fbx, drop it into the root folder of my project Asset Explorer here. It's going to automatically create a folder for it, upload the FBX, convert it to a GLB, and here's what I'm left with. And it did all that automatically, right? All I had to do was drag and drop. Now, let's get this template into here. Let's get an animation component added to this, and we'll add the default animation state graph. But over here, we want to add the animation from spot swing to that. Now we need to put the light, this light, into the bone. This is probably going to move. It's going to reposition things. So let me move the spot rig up a little bit higher near where the light already is. Then I'll drop that light here into that bone. Wonderful. However, it wasn't perfectly aligned. So see up here the position. This is the local position for that spotlight. It's not at 0. I'm going to 0 it out. And this is because I drag and dropped something into the bone. If I would have right-clicked on the bone and created a new entity inside of it, like birthed it inside of there, it would have been zeroed out automatically. But when you drag and drop something that already exists into the hierarchy somewhere, it doesn't move the position of the thing. It adjusts the position to leave it where it is. So went in there, zeroed it out. We're looking good. I think I'm ready to go in here and refresh and see what happens. Well, I can tell already it's working. My spotlight is moving around, and that's the one that casts shadows. Now you'll notice the shadows that it's casting aren't moving. And the reason for that is the position of the light is not changing, only its direction. If I wanted the shadows to move around all crazy, all I would have to do is make the light move its position a little bit, and then that means that the shadows it casts are going to be at a different angle. And if I was actually trying to make a lamp that got hit by a grenade and was swaying side to side, I would do that, because when you think about a lamp, it's not just a spotlight rotating along its origin. It's a lamp hanging from a rope that's swaying, and the light source is down here. It's actually changing its position, and that's why you get crazy dancing shadows with that kind of stuff. Let's do that, and let's do that all inside of Play Canvas without even going back to re-export the animation. Easy peasy. So what I'd say, there was like some distance between the origin and where the light is hung. It's a Unix system. I could do this. I'm just going to grab my spotlight and move it down 0.5 meter. Now, when the light's swaying back and forth, it'll have a bit of a different effect. It's not as dramatic of an effect as I was hoping. Maybe if I move it down further, we'll have a more dramatic effect. That's all right. If it doesn't get as dramatic as I'm hoping, I'm just going to put it back to what it was. Let's see. Let's stand in here. What are we doing? Yeah, you see how my shadow... Now, it's not as dramatic as I wanted, but see how my shadow is actually moving? Like where my feet are. You'll see when it comes back over here. It's actually moving because of where the light position is. The more the light position moves, the more you're going to get that effect. The effect is not very good because I don't like the shadows that this is casting. So I'm just going to undo those adjustments that I made. That's going to put the spotlight back to where it was. The shadow of my guy there, it's not going to dance anymore. It's just going to stay kind of constant as the light sways, the orientation sways back and forth. But that's okay. I think that looks a little better than the hard to understand shadows that were happening a moment ago. Cool, so we got a spotlight moving on a pendulum. We have a ship type light flying around. We have display shelves rotating. That's some good stuff. Now you'll want to create animations that loop so you get the most out of them. So rotating animations, they go a long way. Like this pedestal thing. There is tennis shoes sitting on a pedestal, but also if I went in there and I added some stuff like a satellite sphere out here, smaller, and this one we're going to give it a material also. This one will be blue glow. For emissive, I want it to be blue. And for diffuse, I want it to not be so blue. I want it to be black, so it can actually show up as blue. So, where did I put that? It was in there, huh? Okay. Now it's assigned. We'll see that my orb is kind of like full at there. Oh, first of all, the orb is orbiting around the origin. So instead of tennis shoes on the pedestal spinning, now we have a planet orbiting the center of the universe. So we're getting multiple uses out of that one animation. It's just it's rotating. You can get a lot of use out of the pendulum one also. But this blue light, I want it to emit light, not just look like it's emitting light. I want it to actually emit light. So we're going to add an Omni to it. We're going to add it to the bone. We don't need to add it inside the sphere because the bone is what's animating. We got an Omni light here. I'll put it over the ball. I'll make it blue. Reduce its range. Something real small, but its intensity way up. Okay, now we see that the blue light, let me make it not be such a harsh fall off. That is weird. How about range is 3? Yeah. We have our blue light, mega intense, rotating and emitting light. We have the spotlight pendulum going back and forth. And we have the flying one. Cool. Let's see here. How about we show an animation, like a keyframe animation for a model that we get off of Sketchfab. Okay. Sketchfab is a wonderful place to grab assets. They call it sourcing assets when you try to find assets to use in your own projects. We're going to source some assets over here. This guy, this smart drone, let's download him as an FBX. Cool. All right. Now that he's downloaded, we'll just go extract. There he is. All right. His materials are not packed into all into one file. That's unfortunate. That's okay though. It's a Unix system. I know this. We're going to upload the smart drone. Give it a minute. I checked that box. It said to create a new folder for FBX import, and it did. This model is going to take longer to upload, so be patient with me. It might have the materials built in. I assumed that it didn't because it also gave me the materials outside here, but it could be that they were also built in, and I won't have to do anything after I import this, other than drag and drop this thing. Okay, my internet is taking a little bit of a break there as I upload, but I think we're good now. We're good. Okay. Yeah. So it just finished uploading the FBX in a moment. And then, there we go, it's going to automatically convert that to a GLB, as well as create any materials or models or materials and stuff that were embedded into it. And I think I saw some JPEGs. Yes, sir. As long as they load in. Oh no, there's 0 bytes. This thing is bugged out. Oh no, they're not 0 bytes. They're loading in. I just needed to be patient. Because those are huge textures, 6 megabytes each. Wow, that's not how you do web. Okay, we won't worry about that right now. I would have to optimize this before I actually publish this and put it onto a parcel, because I would want it to be really small texture sizes, everything small file size, so it could pretty much instantly load on mobile devices and not lag up or anything like that. But here is all of the assets contained in that FBX. I'm going to drag and drop the template over here. Okay, and there is our monster, I'll call it. I rotate it over here. There we go. Let's make it a little bigger. so we can see it better. All right, and I'm gonna move it to the corner because I kind of want to give it its own light too. By the way, the engine that Somnium Web runs on, it's recently been updated to handle lights a lot better. It's called clustered lighting. If you go to the settings, the play canvas settings here, and you go to rendering, it's automatically turned on, this cluster lighting thing. And it allows you to have multiple lights that turn off and on without super substantially impacting the performance. So you can have multiple lights in a scene and it will still run on mobile because clustered lighting is getting better every day in the Somnium WebWorlds SDK here built on top of the Play Canvas engine. They're also adding things such as built-in GPU instancing, which is huge. If you're a nerdy person that likes games, you'll be like, well, yeah, how are you going to live without automatic GPU instancing? Well, now you don't even have to think about the answer to that question because you don't have to live without it. It's being added along with the GPU instance lighting, which is automatically taking effect with the clustered lighting here. Okay, so if I walk, let me refresh. Refresh because I just added a new model. Walk over to my dude over there, my robot dude, and see what he has to say. And this robot dude is going to have nothing to say. He's sitting there static. And the reason is because I have not applied an animation to him. And that's what today's all about. Applying animations. So I showed a path animation, a few ways to use rotating animations, a pendulum for the spotlight on top. Let's add the skeletal animation to this guy. He came with animations. Thankfully, I'm not going to have to animate this dude with his 7 limbs. But I do need to give him an animation state graph. So, smart drone. We're going to add a component and its animation. For the state graph, I could create a new state graph, but I'm using the most simple animation state graphs known to man. So I don't even need to do that. I could just go grab one of the other state graphs and drop it in there. And now that I have the animation state graph in there, I can apply my actual animation, which is, only one animation came with this model. There it is. And there it is. Oh, he's not happy now and he pulls his gun out. Bang. Okay, so there's skeletal animation. That one was super easy. Let's see what we can do with that gun. What's the hierarchy here look like? We got arms, we got feet, we got pivots. Do we have anything for that gun? We might not. I don't know if there's a bone for the gun. So let's not worry about attaching this thing to the gun. I just want to put a yellow light in front of this dude because he has a yellow face most of the time. So I'm going to right click on the root and just do a new light, an Omni light. And I'll put it right in front of his face. Okay, here's a tip though. You normally, if you care about optimization, and you should not be using Omni lights for everything. In fact, you should be using Omni lights as little as you can, and you should depend more on, let me position this where I want, spotlights. You should depend on spotlights. That light doesn't look good. I'm just going to remove that light. The reason you should depend on spotlights is because shadow maps. An Omni light is like it's like 6 spotlights when you consider the texture memory from shadow maps, because it has to project the light in every direction. And there's 6 directions when you think of like the positive or negative. There's X left, X right, Y left, Y right, Y Z, X Z. I'm sorry, X Z, Y Z. No, Z up, Z down. That's why I got confused. Left and right, up and down, you know, kind of forward and back. Anyways, you got 1, 2, 3, 4, 5, 6 directions. And when you have an OmniLight, it casts light in all of those directions. So you're actually resulting in a shadow map that's either 1/6 the quality or 6 times the size, which is usually the way that it goes. Now, when you create a spotlight, like the one that's on that pendulum going back and forth, it creates exactly 1 shadow map because it only casts its light in 1 direction. So if you can help it and you're trying to be optimized in your builds, in your web world builds, you want to use as many spotlights over OmniLights. Directional lights, they're pretty, I'm pretty sure they're more optimal than OmniLights, but you usually don't want to be casting shadows from a directional light unless you're okay with potentially everything casting shadows. Shadows are the biggest performance impact on things like mobile devices and stuff like that. Real-time lighting, and then right after that is shadows. So you do not want to have a whole bunch of lights that have shadows enabled. In fact, you probably want between 1 and 0 lights that have shadows enabled if you were targeting mobile. If you weren't targeting mobile, it doesn't really matter too much. Let me go over here and show you what I mean. I could be turning on spotlights. I could be turning on shadows for this Omni. I could be turning on stuff for shadows for the red thing. And now you'll notice that every single one of the lights, all 3 of them that I put into here, are casting independent shadows. When that red thing gets near the ball, you'll see it casting shadow. Yeah, the shadows are going nuts right now. And it works fine on desktop computer. You really don't have to worry about it. You don't have to worry about much on a gaming computer. The thing is, when you're building a web world, it's super low friction. That means that people, all they got to do is type in the address to go check out your web world on the parcel that you assigned it to. So you get a lot of traffic. You get a lot of traffic from people on their mobile phones. You get a lot of traffic from people on subpar mobile phones, because why not? It's so easy. They just got to click the link to check it out. They'll check it out. Now, that's when you got to make the decision of like, okay, am I going to make a world that loads really, really quick, has nice low resolution textures, it doesn't use too many real-time lights or real-time shadows, so it runs at a nice frame rate on even a crappy mobile device that comes and visits my web world? The answer to that question is usually yes. That's what you should do, because usually, because that's going to get you the most people into your world with a happy experience. They won't be like, why does it take so long to load, or why does it lag me down? Because you optimized it. Now, if you throw something like this at it, honestly, this would probably work fine on mobile also, because the engine's really good with batch rendering and clustered lighting and stuff like that. But the more lights that you add, the more low-end mobile devices you're going to start pushing out of having that good experience. So if I added 5 more lights, it would definitely work fine on a gaming computer like I'm on right now. It would probably work fine on a good phone, like an iPhone, like the new iPhones or a new Android. But the people on the older devices, they'll start to suffer. So just keep that in mind. Optimization. Optimization is huge. Not only with the textures, not only with how your use of lighting and shadows, which is really important because both of those impact runtime performance. In other words, if you have too many lights, if you have too many shadows, you're going to get a bad frame rate. People say that it's choppy. The other kind of optimization that you need to keep in mind if you want to target low-end devices on mobile phones, and this one's more about devices that have bad internet connections. Let's say somebody's on their phone flying down the freeway at 90 miles per hour. That's too fast. You're not supposed to go 90 on a freeway. But you're flying down the freeway, you're not driving, you're playing the Somnium Web on your phone, and you have a shoddy internet connection. the way that you make your web world load quickly, even on devices that have shoddy internet connections at the time of accessing your web world, is you just have to compress things. You have to use low resolution textures, and you have to use basis compression on your textures to keep the file size really, really small. Small files transfer quickly, so the shoddiness of the person's connection would be presumably not even noticeable if your textures are low enough resolution, because in that 100 KB little jump that it's able to get through the connection to the cell tower, it's going to get like all of the textures. It's just in a few KB. So you don't need a robust internet connection in that case. And that impacts load time. So the real-time lighting, real-time shadows, that impacts real-time rendering during runtime. Textures, they mostly impact load time, how long it takes your app to load. There are certain cases where your materials could impact runtime performance, like if there's a lot of expensive shaders on it. Expensive meaning resource intensive kind of expensive. And that, like a whole bunch of bump maps, normal maps, height maps, all layered onto the same texture with transparency and stuff like that. Because every time you add a new material or certain material layers, you increase what's called draw calls. And draw calls are your enemy when you're optimizing towards web. In general, you want to, like anywhere, you just want to have as few draw calls as possible. So you want to use as few materials as possible, and you want to eliminate any unneeded shaders in the materials. Let me show you what that means. We'll use this little guy over here as an example. What up, buddy? Let's look at your materials. This is really, really good. Now check this out. This is what's called a texture atlas. It's all of the different parts of this thing rendered onto one texture sheet. Now remember I said the fewer the materials, the better? Instead of this thing being 20 different materials, they baked it out into one material. Whoever created this art asset, the person on Sketchfab, they baked it out into one material, and that material only uses one draw call to render all of these parts until you start layering a bunch of shaders on it. Then it could start increasing draw calls. But as far as texture, the amount of materials, this thing gets an A+ because it baked it all onto one material. Okay, what else can we do? How else can we judge this thing? We can judge it by the texture resolution. This is a 4K texture. This thing gets an F when it comes to texture resolution, grading it as far as optimization goes, because there's two things you gotta worry about texture resolution there. One is a higher texture resolution increases the file size of the texture, which increases the load time. 4K textures are about the max that you really want to go in a normal scenario, but that's like a normal desktop scenario. When you're going into mobile, you got to take all these people on their shoddy phones into consideration if you want to do that, and you should. And you have to start worrying not only about the transfer speed, but texture memory, video memory, VRAM is what it's called, video memory. A gaming computer, such as mine, might have 24 gigabytes of VRAM, such as mine. And that's nuts. I mean, you can imagine how many compressed textures you could put into 24 gigabytes of VRAM. All of them. You're not even going to have to worry about running out of texture memory. But when you go to a mobile device, their GPUs are usually, they're tiny, thin mobile devices, right? They're literally like almost paper thin. Literally almost paper thin. So their GPUs, if I held up my GPU from my gaming computer, it's like this big, and it's gigantic. So if you're targeting the more compact, more conservative devices, even if I'm not saying that web GPUs or mobile GPUs are bad. This phone here, this is one of the fold phones. It could run some awesome games on it. It could run Somnium Web, no problem. But if you're targeting web, you got to think about the spectrum of phones. And there's some people on some really old phones that don't have good GPUs, and they particularly have very, very low video memory, so they can't hold a whole bunch of texture space in memory. Absolutely need to be concerned about that with your web world assets that if you're going to be targeting mobile, and you want your texture resolution to be small. This one was 4K. I would lower it down to 1024 to be optimal. So when I do the optimization step, if I were to publish this world, I would go in there and I would just download the texture, or I'd resize it to 1024, then I'd re-upload it with the same file name, and that would overwrite what's already there, and it would be beautiful. Okay, then it'd be time to move on to the next step. What is the next step? Okay, the next step is trying to slim down all the material shaders. So when I look at the smart drone material, I'm not just noticing that the diffuse texture is 4K, but also the specular texture is 4K, the metallic texture is 4K, the roughness is 4K, the emissive is 4K. Why is this image 4K? Most of it's blank. So these are the kind of things you have to keep in mind when you're designing your actual asset. Now this asset I sourced from, it was already made, but if you're making your own model, your own asset, you got to keep these kind of things in mind, because you don't want to waste all this texture space. Sometimes doing an extra jaw call is going to give you is going to be the wiser choice than making a 4K texture that you only use a tiny happy face of, because this emissive map is a 4K texture. So another F on this thing for being a 4K texture and having all the wasted texture space. I'm not talking down about this model. This model is a wonderful, beautiful model, but it's just, we're trying to optimize it for web, for mobile phones, for low-end mobile phones specifically. And when you do that, your grading scale becomes much more rigorous. You give out a lot of Fs when you're trying to optimize towards a mobile phone, a shoddy mobile phone. Okay, so we got materials. Every single one of these materials is 4K. So I would go and resize every single one of these materials to be 1024 or 512, preferably 512. Can't go too low though, because you're going to start seeing blurriness and pixels and stuff. 512 is a good thing to shoot for. Sometimes for some materials you can't go lower than 1024, because then you're going to start seeing artifacts. So we got all these different material shaders. Now, let's see if we can eliminate some of these material shaders. How would this thing look if it didn't have a normal map? Well, let's find out by changing its bumpiness to 0. It looks different. It looks different. This bump map is important, I've concluded, and here's why. Yeah, when I turn it down, it's kind of not noticeable here. But normal maps, they receive lighting. So when, let me get the camera real close to this thing. You see how you can, all those little grooves, the places where the bolts went on this model here, like where you can imagine the bolts go. You see them taking light as if they're actual 3D geometry, but they're not really 3D geometry. And the only thing that's making them look 3D is how normal maps receive lighting. Normal maps make flat surfaces look very 3D when they're hit by light in a certain way. And when you have moving light sources, it is immensely powerful to have a good normal map, because then you actually get to see the different colored lights hitting each little edge of these bored out holes where the nuts and bolts went on this robot. And those are just 2D, they're just flat surfaces. They only look 3D because of the normal map. So normal maps combined with moving lights equals an impressive result. So we don't want to get rid of the normal maps on this particular model. I've looked at it, I've made the judgment call, the normal maps are important. Okay, what about these other things? What about the glossiness? What happens if I take the glossiness down to 0? It looks a little flatter. It still looks pretty good. I'm looking at the nuts and bolts there, where the lighting would be most prominent. It looks all right, but when I compare that with what it was, I think that it looks much better the way that it was. Yeah, it looks way more 3D. How about metallic? What if I took the metallic away? That's no good either. Okay, metallic. So, if any of those material shaders, the layers of the material, diffuse, specular, and see how they each use a different image? The goal of what I was analyzing there is I wanted to remove images. I wanted to, okay, if there wasn't a big impact from the normal map, I wanted to click that little X and just remove the normal map. If there wasn't a big impact from the glossiness or the specular, I wanted to click those and just remove them. But they're all used. They're all important. This is the centerpiece to the stage. Obviously, it's the most interesting thing here. So I'm going to leave them all there. I could put this model on the pedestal to let it spin by parenting it to that rotating bone, but I won't. I'll leave it over there. Let's finish up these thoughts about optimization. So how could I optimize this guy? He's the center. He's the focal point, so I didn't want to sacrifice any by removing any of these textures, these material channels. So definitely, I could resize all the materials down to be 512, then re-upload them, and they would be looking better. Now there's another step. This other step is called basis texture compression. What I'm about to show you might not seem substantial, but I'm telling you, after you get some experience building web games, stuff like the ease of which that I'm about to do this is something that you'll be seeking. And now I want to compress all these textures. Now, normally I would have resized them first down to 512 by 512, and that would have instantly taken their size here down to a few hundred kilobytes instead of megabytes. But I'm going to skip that step because that's a boring step of downloading and resizing and re-uploading, and I just want to show you what the compression is. So I multi-selected these big materials here, and then I went over to the asset properties and scrolled down to where it says compression. Checking the box that says compression. Then I'm just clicking compress, and I'm twiddling my thumbs here because now the Play Canvas editor here in the web browser, it's compressing all of those textures in a very awesome way that I could go on and on about for at least 5 minutes, maybe not hours, about how not only is this thing compressing the size of the materials, as in like kilobytes, while it's being transferred, it's also compressing them in such a way that they are going to consume less VRAM. And that's huge. And it's going to show me how much less VRAM after it's done compressing. And I click on these things one at a time to show you. But it's going to reduce. So what does that mean? It reduces the file size. That means my app's going to load, my web world's going to load faster. And then it reduces the VRAM, which means that the shoddy lower-end mobile devices are not going to run out of video memory as quickly because there's not going to be so much consumed by this. Running out of video memory is your worst nightmare. Apps cannot function when they run out of video memory. So you got to be aware of like, hey, if you want your thing to run on a low-end device, you have to be hyper aware of video memory and keeping it really low. These things, they're still working through it. I gotta wait until they're done before I can show you the results. And they're taking longer than optimal because they're 4K textures. You would want to resize them down before you apply the basis compression. I just applied it to the big ones. It's going to be more substantial because I'm applying it to 4K textures, but just 4K textures you in general don't want to use if you're targeting web, unless you absolutely have to. There are some cases where if you have a massive terrain, you will need 4K in order to get the level of detail you need in the height map or something like that. But for something like this guy, you definitely want to bring him down. Okay, this is going to take a little while, it looks like. So let's walk around the test world while we wait for that. Okay, what else can we demo about animation? Now, you can do a lot of creative things with animation. And I'm going to make something go up and down real quick while we wait for these to finish compressing. Let's go back into 3ds Max, reset to a new scene, speed run this. We're going to create something from a system. It's going to be a bone. All right. I'm going to take off the rotation on that bone. doesn't have any rotation. I'm gonna center it up here. Now this thing, let's make it go up and down, up and down. What is this gonna look like if it goes up and down? Oh, how about instead of up and down, we make it look like a car. Let's say that we're making a street and we need to make traffic. We need to make traffic on a far off street that just looks like it's driving by. Shoo, 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 shoo. Okay, hang on. This is a Unix system. We know this. We got our bone. It's gonna start here. Start there. And then we got, let's make it a 200 frames in our animation. And over here at the 200th frame, we want it to have driven down the road. Over here. Okay. Now, when I play this, we'll see that the thing is going to go, it's going to, oops, play it here. It's going to drive down the road, imagine it's a car, and then it's going to snap back. Bam! It didn't interpolate back, it snapped back. And that's all has to do with how you, your animation program works. I'm using 3ds Max, Blender, Cinema 4D, Maya. They're all going to be pretty similar. And to get the actual animation curves that you want, you're going to have to learn something called the dope sheet in every single one of those. But this is good for right now. I don't need to worry about the ease and out functions here. Let's see what happens when I export this thing. Oops. Oops. File. Export. We'll call this car anim. And animation, baked animation, looking good. Okay, hey, my textures are finished. I can say some more stuff about that. So this texture here, it is 1 megabyte large when it's transferred. It takes up 11 megabytes in VRAM. Now that looks like a lot. You're like, hey, 11 megabytes in VRAM, it only was 5 megabytes in texture size. But that's expected because when a model gets loaded into VRAM, it's especially if it's a JPEG, it gets uncompressed in a very unoptimized way because JPEGs are compressed, by the way. And it's kind of like a raw image when it's sitting on your GPU. So if this wasn't basis compressed, I should have checked before I compressed it. It would have taken up tons of space in VRAM. Oh, it doesn't tell you if it's not compressed. Oh, okay. All right, anyways, going back to this one, by clicking on any of these materials, it'll show you how much it's compressed. This one, here, how about this one, the metallic. It used to be 5.7 megabytes on disk to transfer. Now it just transfers 1.32 megabytes, and it takes up 11.2 megabytes in VRAM, which is actually lower than if I just loaded the JPEG. So basis compression is something that you want to apply. You want to apply this at the end, near the end, when you're at the optimization phase. Now you got to think of optimization the whole way through, but certain things you actually want to save until the end, because if I'm swapping these textures out and I'm changing them around, I'm adjusting their color, I'm changing their size, their resolution, and re-uploading them, I'm going to have to re-compress them. So you just save that compression until the end, normally. Do all the resizing and recoloring or whatever and re-uploading, but don't go through the effort of selecting everything and clicking basis compression until you're sure that those are the materials that you want, because otherwise you're just going to have to do it again. Okay, before I go on a little bit more about optimization, let's get this car that drives back and forth in there. I got some time here. Yeah, I got about 20 minutes, a little less than 20 minutes. We're going to, first of all, let's go to the root, make sure that I'm creating a new FBX folder for my asset tasks. I am, okay. This FBX car animation, drag and drop it in there. That's gonna upload the FBX, then automatically convert it to a GLB and give me my template and my animation as separate objects there. Cool. Let's spawn this template in there. All right. I don't know what direction this thing's gonna move yet. We'll figure it out in a minute. We're gonna add an animation thing to it. I could create a new state graph. I'm gonna do that just in case somebody missed it before. I could use the old one because it would be the same. Because I'm making the most simple animation state graph known to man. In fact, I don't even have to edit it. I just have to create it and then drag and drop it. Don't even have to edit it. However, if you click on it and you go to the animation state graph editor, it is actually really, really cool. And there's a lot of different things you can do here. It takes some learning to know how to do this, but you can have multiple states that transition from one to the other. So basically animations. You could have different animations that go from one to the other. You could have animation layer masking. So yeah, your animation only impacts certain layers of the model. All kinds of cool stuff that you could do, but is not needed for the simple thing that I'm doing. And that's to make a car go back and forth. So here's the car animation. I give it the animation there, but I don't have, I have a bone that would move back and forth, but I wouldn't be able to see it. To do that, I need to add something to my bone. So over here, new entity 3D, we'll make it a box. I'm gonna scale this box to be more car shaped. Yeah, and you know what? I might get crazy with it. Let me raise this up a little bit, or actually I'll move this over here. Let's make this an actual car. Why not? 3D cylinder. There's a tire. I'll only give it 2 tires. We don't need 4 tires. We're a crappy car. Like I was saying, this could be a car that's off in the distance. You're not even be able to see it from the other side. It doesn't need 4 tires. It only needs 2 tires. But it does need a cab. Oh, it could be a truck. We are a truck. Yeah, that's what I'm talking about. So we have a truck. Let's see it drive. Now the thing is, I didn't center the truck, so the truck's gonna drive off. That's not what we wanted. We didn't want the truck to drive off because it's gonna teleport back and then drive off again. And that's weird because we don't want to see it teleport back. So what we're going to do is center it up some, which means moving it way over here so we don't see it spawn in, we just see it drive by like traffic. So we're here, we're checking out the stuff over here in the main play area, and then all of a sudden, and we don't see it drive back, it just keeps on going like it's a different truck every time. Going, awesome! That's one way to do traffic. I'm going to go off of a little tangent here and say, a trick that you can do to reduce the amount of cars that you have on your distant road. So I'm talking about for this truck putting traffic on a distant road that the user doesn't get really too near. Instead of having one truck just go over here and then snap back and then go over here, you could make a path that is a loop and the truck goes over here and then it turns around. Out of sight, out of frame, right? It's way over there, so you don't see it turning around. But it just turns around and then it comes back the other way. And then it turns around and it goes back this way. And it turns around and it goes back that way. You get more of a varied traffic response, more of a varied traffic look like that. If you have like 2 or 3 of these vehicles that go down a road and then turn around and they kind of do a loop up and down the street, you have like 2 or 3 of those going at different speeds. And then you start getting cars that they're not always in the same pack. It's not always like a truck and then the other car that's 5 meters behind it going down the road. You have like a truck that goes the same speed and then goes back, but its duration of its animation is different than the car. So the first time they look like that, but then after that they start getting out of sync. And that's what you want, because when things start getting out of sync, you got this, by out of sync, I mean their animation sequence gets out of sync. They're not doing that kind of dancing where everybody... Synchronized swimming. Yeah, sync is the word that I was going for. They're no longer synchronized swimming cars that are always doing the same thing. They kind of have a little bit of... They have what appears to be a little bit of randomness to them. Cool. Okay, so there's that. We got traffic. We got a truck that drives by. I'm going to put more tires on it because it turns out that you can see more tires. So now, Now we got all the tires that we need. Cue the truck. And it has all of its tires there. So there's some stuff you can do with animation. And just to recap, the workflow that I'm doing here is I create an animation in 3D modeling software such as Blender or 3ds Max. It could be path animation, like animation constraint to a spline. It could be keyframe animation. It can't be morph target animation. I can't grab the vertices and try to animate those because those aren't going to export well to an FBX. So it's got to be skeletal driven, bone driven. So that's a constraint along a spline. It's just moving the object around like I did the truck, like this one right here. This is the truck bone, just driving down the road. Or it could just be spinning or going back and forth. Now, I did demonstrations of all those different types of things here. And from the animation that I did here in the 3D modeling software, I export, I make sure that I bake the animation. Export the animation and bake the animation. If your software asks for that, it might be that it always bakes it, depending on what you're using. After I export my animation, which is nothing but a bone that's animated, I import it into Play Canvas, and I attach things to the bone because the bone is what's animated. So on this bone, I attached all these different objects to kind of create a car. On this bone, I just made this little cube that spins and called it shoes, so you can imagine it shoes. On this turntable bone here, I put two objects attached to this bone so that they could kind of orbit around each other. Also over here, I did add a little orbit thing here. I used the hierarchy to put like a light that also was going to rotate. It would orbit. So the difference between rotating and orbiting is your object is sitting right there on the axis of rotation. Orbiting is when it's away from there and it kind of does this kind of thing, if that showed up well on my webcam. You know, like planets do. Yeah. Okay, animations. The wonderful world of animations. We covered some optimizations. I'm not going to publish this world because I would have to optimize the textures and everything before I did publish it through it on a parcel. But, oh yeah, I skipped a step. Created a animation state graph. So after I imported the thing and after I I attached objects to the bones of it, I added an animation component to the top level object here. And then I assigned my animation state graph to it, which then let me assign my animation. And that was it. Then I would go in here and test it and see it. Okay, I'm approaching the 11 o'clock hour here. I hope that was, or will be, VODs, or was for people watching live, useful for people trying to figure out how to bring some more liveliness to their web worlds. Keep an eye out for the next Web Worlds SDK update, because we're on version 1 right now, version 0.1 of the Web Worlds SDK. With each new version of the Web Worlds SDK, there's going to be more interactive objects that you can do. More examples of things like the web browser on the side. More templated interactivity. And with each little thing that gets added, you'll be able to utilize it to do a lot with it. Like, this is just animation, no scripting. I'm not using any scripting here. Just throwing animation loops at this thing, and we got all this motion going on. And there's a web browser object. And when I assign this to a parcel in actual Somnium Web, right now I'm just in the tester thing here, that would be an interactive web browser. I'd be able to click on it. It would load up the web page right there if it was compatible with an iframe, all that good stuff. So let me go turn off my little tester man. And this is basically what it would look like on a parcel. You'll want, if you're doing a holistic world, you got to be sure to throw a skybox in there. If you don't want to deal with the skybox and you're okay with how parcels work in Somnium Web normally, with the whole day-night cycle, you know, it starts at daytime and the sun goes down and the moon comes up and it's nighttime and it just does this cycle. That's pretty preferable in a lot of cases. Like if you're building an outdoor scene, Maybe you'll want to fine tune the light to like always be nighttime and cast the exact shadows that you want, but keeping that dynamic of the day-night cycle is pretty interesting. You use a holistic web world. Holistic web world here if you want to control everything. So if you want to assign your own skybox, like your own texture for the stars, and you want to define your own lighting situation for how bright it is at nighttime in your world, you would do holistic. That's everything. You have control over everything if it's holistic. If you do an augment world, it's going to add what you build to what's already on the parcel, and it's going to keep that day-night cycle. It will ignore whatever skybox you have, and it's going to keep that day-night cycle because you're just augmenting what's normally on the parcel with your new stuff. Let me show you a little bit of what this would look like with that. Unhide my dude. Okay, so here's a holistic world where only the stuff that I built in this scene shows up, right? It looks identical to what I see in the editor. However, now that I switched it to an augment world and I reload it, you'll see that it has a parcel. The parcel is here because when you do an augment world, the parcel is there. Not only the parcel platform, but the actual parcel build is there. Like if you make a building and put it over there and you put your NFTs in there, it'll still be there when you do an augment world. So you just got to decide what world is best for you. Do you need that total control, or do you want to merge what you created with what's already on the parcel? And that's the two types of worlds there, and I think that's going to be bringing us to the conclusion of this kind of demo session here. I changed it back to holistic world. I'll refresh here. I prefer usually to do holistic worlds because that's like building a whole scene that's immersive. The thing is, you can share your web worlds. So you could build an augment world that you put on your parcel, and it adds, I don't know, it puts Christmas trees all over your parcel and makes it Christmas themed. That's a holiday coming up, right? But if you make it an augment world, you could give the URL that you're hosting to your friends for them to put on their worlds, and both of you guys could have Christmas themed worlds using the same augment web world. Let's say that you had like a guild, like a group of gamers or something, and you all had parcels. And you all built your individual buildings on there, but you wanted it to look like you're all tied together in the same kind of community because you're a group, you know? So a great way to do that would be create an augment web world that adds all of your branding to the outside. So let's say that you're pro gamers, it adds your billboards for your pro gaming group and like giant controllers and giant gaming PCs just sitting around your environment, like outside of the parcel build. You assign that to your world, all of your friends assign it to their worlds. So whenever you visit any of y'all's parcels, it has this consistent kind of theme to it with the augment web world spawned around it, but each person still gets their unique content on the inside. And you're binding your community together by sharing one of your augment worlds. And just one more thing about that before I wrap up the stream here. Let's take that a step further where, okay, you and your group of friends, you all have parcels and you have the same augment world assigned to all of them. And let's say that you are the creator of that augment world. You could go in there and you take down your billboard and you put up the new billboard for the upcoming tournament, like the tournament that's a couple weeks away. Because you're trying to get people psyched up for it. You want to put some YouTube videos in there of how you did on the last tournament. So you go and you get some YouTube links from what you recorded from the last time you and your pro gamers were in a tournament. You throw it in there. You update your web world. Instantly, all of the other parcels that reference your web world get your updates. So the next time you visit any of the parcels in your little community of parcels there, you're going to see the new YouTube videos, the new banner that's promoting the upcoming tournament instead of the old tournament. So you can use augment web worlds as a way to kind of put dynamic content across any number of parcels. And for real, the last thing I'll mention about this is you control which parcels can use your web world right over here. The same place by clicking on web world prefab. The same way that you change between augment and holistic. You could change the allowed parcels. If you leave it on the default value, it'll work anywhere. Anybody that puts your web world URL onto their parcel, it'll work. But if you wanted it to only work on you and your 2 other friends' parcels, you could say, okay, I got 3 parcels that I want to allow this on. I want to allow this on 338, 8, I want to allow this on 28, and I want to allow it on 311. And if you do that, and then you publish your web worlds and your web world and upload it, your web world is only going to work on those parcels. If anybody from a different parcel tries to use your web world, it's just going to say error and then just load it without the web world, because this is how you restrict who is allowed to use your parcel, or which parcels are allowed to use your web world. And now, okay, let's say you and your 2 friends. That's awesome. You guys have your Augment web world going down for your gaming crew, and you got your branding, your billboards, your YouTube's all on there. But now you got a 4th guy. A 4th guy joined your crew. What are you gonna do? Easy. You just come over here and you change this to 4, and then you add his parcel in there that you want him to use. 287. Now this parcel will work on 287 also. So if you bring more people into your community, them having access to your Augment web world is a perk that you can offer them, because now, since they're in your community and you added them to your little whitelist here for allowed parcels, they can use your web world too. And they can't do that unless you let them. So it's like you're the landlord of who gets to use your web world. So that's just another way to use the Augment web worlds. For that case I was describing, you went Augment. It would work with Holistic too. It's just it doesn't make as much sense with Holistic, because Holistic replaces the whole parcel, while Augment lets people still have their unique thing built on the parcel and then adds the web world around it. Okay, with that, I'm at the 11 o'clock mark, so I'm going to wrap it up. I'll record a little video of all these lights floating around, and I'll post that to Twitter to show people what was going down. And next stream on Monday, we'll be getting into more web world creating, most likely. And not sure what I'll be building there, but it probably won't be more on this. It'll probably be something more substantial that I'll be working towards actually finishing, binding to a parcel, and letting people come visit. So there we go. Animation, optimization, and how to use different ideas about how to use your web worlds. And I'll see you all next Monday, on Monday. Happy Thanksgiving if you're American. Thanksgiving was yesterday. If you're Canadian, Thanksgiving was called something else and a week ago. But no matter where you are, happy Friday, and I'll see you all on Monday. Peace.